Hey guys, we're going to continue our discussion on biodiversity today. Biodiversity, of course, refers to the different life forms found on planet Earth. And I suppose we can simplify Earth's biodiversity with an equation which shows the inputs where one species becomes two, subtracting the outputs where we have a loss of species, and the net result, or the net amount of species on planet Earth, would be the biodiversity. So speciation and extinction are two opposing forces, therefore, that add to or subtract from Earth's biodiversity. So starting with speciation. Speciation, of course, is the process where one species becomes two. And this occurs most commonly in the form of what we call allopatric speciation. Allopatric speciation means, well, literally allopatric means other fatherland. So this suggests that we have a population that gets geographically isolated from each other. And with that geographic constraint, we have reproductive isolation. And as a result, we can have two species emerging from one. So a good example of that would be the early fox population. With our last glaciation, well over 100,000 years ago, we had a population of fox and its gene pool that was ultimately separated from the other population of fox by a glaciated environment. Consequently, we had a fox population inhabiting the glaciated environment of the north and a non-glaciated environment found in the south. Now, that original population had genetic variation. Then the population was isolated from each other. These populations with these geographic constraints are now undergoing independent mutations. Natural selection was occurring independent from each other. In other words, certain traits could turn out to be positive adaptive traits in a glaciated environment, and other traits could be positive adaptive traits in a non-glaciated environment. The environment therefore selected for and against some of these selective traits, and consequently, the gene pool within these two separate populations now changed so dramatically that if these populations were to intermix, they could no longer interbreed. So what emerged were two different species, one being the Arctic fox, adapted to a glaciated or a colder environment where they have heavier fur, short ears to reduce heat loss, and short legs, and a short nose. The camouflage white fur, of course, allowed it to blend in its environment. The gray fox, on the other hand, was adapted to heat through lightweight furs, long ears, legs, and nose. One species became two. Now, this occurs, it takes, generally speaking, especially for these K-selected or slow reproducing species, tens to thousands of years. However, this type of speciation can occur much more quickly for rapidly reproducing populations. The force that opposes speciation, that which produces the outputs of a biodiversity in a population, would be, of course, extinction. This is where one species becomes zero. And of course, extinction events are pretty dramatic as the way they're portrayed in this image. I actually took this photograph. I'm not that old, but nevertheless, extinction is a very natural process. In fact, there's thought to be a background extinction rate of about 1 to 5 species for every million species every single year. Those are background levels. It suggests that extinction is very natural. In fact, when we look at all the organisms that ever lived, walked, swam, or flew on planet Earth, about 99.9% of them are now extinct. And that's what the fossil record tells us. Sometimes these extinctions, though, occur at levels that are quite dramatic, and we refer to these as mass extinctions, where about 25 to 95% of the species on planet Earth at any given time go extinct. The classic example, of course, would be the end of the Mesozoic era. Of course, the mass extinction event of the dinosaurs, which was evidenced by a massive asteroid that slammed into planet Earth. Of course, we can see that rim and that crater off the coast of the Gulf of Mexico, what is now the Yucatan Peninsula. And it's not as though this massive chunk of rock that came from space just slammed into the dinosaurs and they died, but rather it slammed into the Earth and it suspended a huge amount of debris and particulate matter and ash and dust into the atmosphere. That encapsulated the globe very quickly. It blocked out sunlight. Dinosaurs are thought to be cold-blooded, generally speaking, and dramatic climate changes and vegetation shifts resulted in the mass extinction of the dinosaurs. Now, dinosaur extinction wasn't the only mass extinction. There are many others that have occurred before the dinosaur extinction. This is, of course, known as the Great Dying. This is the Permian extinction, when organisms dramatically went extinct following extensive volcanism, where volcanoes pumped a lot of ash into the atmosphere, but also pumped a lot of carbon dioxide into the atmosphere, changing and altering Earth's global carbon cycle and enhancing the greenhouse effect. This, of course, warmed the Earth, cooled the Earth, changed the chemistry of the oceans through acidification, and certainly influenced sea level. These types of global events have caused mass extinctions in the past. The Great Dying at the end of the Permian period was responsible for 95% of the species going extinct. Like I said, these mass extinctions are not solitary events. The most recent, of course, is known as the KT. That's the end of the dinosaurs. We also had a mass extinction at the end of the Triassic period during the middle of the Mesozoic, or age of the dinosaurs, the end of the Permian, which is the Great Dying, late Devonian, and the end of the Ordovician period. So all of them have perhaps different mechanisms that caused the mass extinction, but they're all related to each other in that a lot of life forms were lost. Now, generally speaking, we think of this as a loss of life. However, following some of these mass extinction events, there's a process we refer to as adaptive radiation. That's because now with all these species that are vanished, there's a whole slew of ecological niches that are devoid of life, and they're vacant. And like a vacant building, it allows for new people or organisms to come in and populate and fill those ecological niches. And so sometimes following mass extinction, we see a rapid period of evolution and speciation to fill those ecological voids. You guys are going to be reading up on one of the most famous mass extinction events, the one that we refer to as the Great Dying at the end of the Permian period. And it's a fascinating tale. And you're going to explore the mechanisms that perhaps caused it. So enjoy that read, and we'll be discussing in class. We'll see you guys next time.